In some of the tutorials that you read or videos that you watch on the internet, one thing might surprise you. Things go so smoothly. I mean, the instructor writes a beautiful, flawless code, and without any problem, everything ties up beautifully together. It's like magic. You see them coding and then admire and aspire to be at their level. You admire to be an awesome programmer like them, writing without any mistakes and creating beautiful user interactions without Googling or searching anything on the internet or searching for a solution on Stack Overflow or anything like that. It's simply flawless. Well, let me tell you a secret. That's not how things work in real life. First of all, you cannot know everything, and even for the things that you already know, you still might need to look up. And secondly, you'll make mistakes. You'll make lots of mistakes actually. So I decided to create this lesson from a different perspective. In this lesson, I'll search a lot, and I'll also make lots of mistakes, some of them intentional, and some of them a little inadvertently. But the point is, I'll try to show y'all how things work in real life. And I promise I won't polish anything. I'll just present what I do as I do it. And before I even start, this will be a slightly longer lesson as I'll try to explain my thought process in more depth than I usually do, and also because I'll be showing the bugs and mistakes that I make, which I usually cut out or edit out and remove from the final recording to provide you a more streamlined learning experience. So if this lesson feels a little slower than the others, just bear with me. You'll find it useful eventually. So without further ado, let's begin, shall we? Let's first see what we are trying to achieve here. I'll try to replicate the famous Snake game, and if you ever had a Nokia 3310, you know what I'm talking about, and if you haven't, well, I feel for you. But the rules of the game are simple. You have a snake that moves on the game board at a certain speed on the screen. While it moves, it eats the things that get in its way, and as it eats stuff, the snake grows up, so the length of the snake increases. The only major rule of the game is to not eat yourself, so if the snake intersects with itself, you lose the game and you restart. So first things first, I need a project folder. So I'll create a new terminal session by doing a tmux new-s game. And you may check out the lesson notes on this video's webpage for more information and tips about tmux. And in my terminal session, I'll create a project folder called Snake. Then I'll initialize a project there by yarn init-y. And once that is done, I'll have a project folder to work on. So yarn warns me that this might have security implications. So what do you do when you see such a warning for the first time? Well, you search. And especially you search the official documentation. Well, if you check Yarn docs, they don't tell you what those security implications are. And as a follow-up, when I do a quick Google search on Yarn init security implications, I don't find anything suspicious as well. And when I check the package.json that Yarn init has created for me, I don't see any vulnerabilities in the package.json as well. So I conclude that this initial setup is secure enough and move on. Well, that might sound simple, but it's important. When you are not sure about something, reading the official documentation first, and if you're not still satisfied with what you read, searching and asking further questions should be your default response to anything that you don't fully understand. So always ask questions and always be curious. Now I'll open the folder that we just created in my IDE, which is Visual Studio Code in this time. But as always, you can use any code editor that you feel comfortable with. I want to create an HTML-based game for the Snake game. And when I Google for HTML 2D game, Phaser is the first hit that I get. But I don't want all the bells and whistles that Phaser has to provide, since I'm planning to create something simple. So I click a few links on this page to go to the Phaser's Git source code. Because at this point I'm wondering what Phaser is using behind the scenes, and when I dig into its documentation, I see that Phaser is building stuff with Canvas and WebGL. Well, again, WebGL feels too advanced for my simple 2D Snake game, so I search for Canvas and I see a bunch of links that look like relevant to me. As a side note, I can also limit my search to a certain site, which most of the time I do, and which most of the time I limit my search to MDN, because they do have quality resources that I can rely on. So let's search HTML Canvas site developer Mozilla.org. Then I tap this Canvas API link. Yeah, it looks like I can draw rectangles on this canvas thingy, and it has a 2D rendering context, whatever it is. So that's good enough for me. Next thing that I'll check will be the browser support. So when I go to caniuse.com, which is another inevitable resource that I use all the time, I see that Canvas is widely supported in all major user agents, so I can confidently use it. So let's begin by creating an index.html on the project root. And since I'll need to attach some behavior to this index.html, I'll probably need a JavaScript file. So I'll create a snake.js2 for our snake game. Then I'll open my index.html file and do a bang.html, which is a Visual Studio Code macro to pre-populate the file with some initial HTML template. I'll update the title, and also I'll rename the script to point to the snake.js that we just created. And then I'll move this script to the bottom of the page so that I can reach the DOM elements inside the page without having to wait for the DOM content to be ready. I'll also create a main.css file that this link element is pointing to, and I should be good to go. Now I need a local HTTP server to run my web page, and when I Google for simple local HTTP server, this HTTP-server is my second hit, and when I check its docs, I feel like I can use it as a development server for this project at least, so I'll install it globally to my system. Then I'll do an HTTP-server on my project root, which will start serving this index.html on my localhost port 8080. Let me also split this window and put my browser side by side with my IDE, so that we can see what we create while we work on the project. And then let me add something first to the page, like a Hello World heading, and then save it and refresh the page. And yep, my changes are reflected on the page, so we can move on. I'll also add some basic CSS to the page to test that my main CSS works, and it looks like it does. Then I'll split the window further into 3 parts. To the left is the editor that we will code things in. To the top right will be the browser that will preview and test our game. And down below I'll put Dash, which is a desktop application that helps me search things, as you'll see. You can also search stuff on the internet as well, but Dash provides more targeted results and generally saves my time, so I prefer using it. I also want to do a Flexbox layout for my page. So I search for it and find a mini tutorial telling me about how I can align stuff using Flexbox, and what I want is to center the game container both horizontally and also vertically on my screen. But before that, I want to apply a global CSS reset to the page by doing an asterisk margin 0 padding 0, which will remove the margins and paddings from all the elements on the page to normalize how they look across browsers. And normally in a production application, I wouldn't use this hack, and instead I would use something like normalize.css or maybe a Mayer reset. But this is just a demo game, so this simple global reset hack will do the trick as well. I'll also change the background color of the body element to be a little darker and set a default sans serif font, and things begin to look a little better, I guess. So what I want is to center this hello world both horizontally and vertically, and in the Flexbox docs it says that align items attribute does the horizontal alignment and justify content does the vertical alignment. But when I do align items center, justify content center on the body element with display flex, it only horizontally aligns the content because this body element is not spanning the entire height of the viewport at the moment. So I'll do another neat trick and give height 100% to HTML and body elements so that our body will span the entire height of the viewport vertically. And that fixes our problem, and the text is centered both horizontally and also vertically. So instead of a heading, I'll put the canvas item for the game here. And again, when I search for how to create a canvas element, I see an API documentation on MDN again, and also some basic examples that show me how to do so. So I'll give my canvas an ID, a width and a height, and see how it is rendered on the page. Well, I don't see anything, so let's try giving some background color to the game container. And there it is, we have our canvas neatly centered on the page. But because I love my eyes and I want to use them later in the future, instead of this bright, vibrant yellow color, I'll give my canvas a tiny white border instead, just to see where it's located, and I'll remove its background. Now I think it's time to render things on the canvas, which we'll do with JavaScript. So I'll go to Snake.js and create an immediately invoking function expression, or an IAFE, because for this game, to keep things simple, I'm not using any bundler like Webpack or Rollup or anything like that. So I'll create an isolated context with an IAFE instead. And as always, if you are curious, and you should be, you can search what an IAFE is on MDN. But back to our game. Again, searching the docs, I realized that I need something called a context to render stuff on the canvas, and in our case, I need a 2D context, so I'll create references to canvas and a 2D context on my file. I'll also replace this function with a fat arrow because it looks neater, and then I'll log context to the console to verify that I actually have a reference to the context, and it looks like I do. And now I need a game loop. And when I search for game loop, I find this Anatomy of a Video Game article on MDN, which provides an example of how you can use request animation frame to create the main loop function of a video game. So I'll just follow along with the example and create a loop with request animation frame as well. And yay, it looks like our game is looping the loop. But this loop at around 60 frames per second is a little fast for our Snake game, so we might want to slow down the game a bit by intentionally skipping a bunch of frames. For that, let's define a frames per iteration constant, and I'll initially set it to 4, and I'll also define a counter, and if the counter is less than frames per iteration, I'll simply return, and if not, I'll reset the counter and continue with the rest of the game logic. I'll also put a math.random here to better see how fast the game ticks. And now it's relatively slower, and if I increase the frames per iteration, you'll see that the game loop will visibly slow down. So for now, let's keep it at 16, and we can adjust it to our liking later. And let's do some basic math. This canvas is 400 pixels, which means I can neatly divide it into 25 by 25 16 pixel wide squares. So I'll define these numbers as constants as well. The size of the square, which is our grid width, will be 16 pixels, and we have canvas width divided by grid width rows, and again we'll have canvas width over grid width columns, which will be 25 too, because our canvas is a square. And therefore the width and the height of our canvas are the same. Now I want to render the apple that the snake is going to eat on a random square. When I search Stack Overflow on how I can create a random integer within a certain range, I reach at this nifty little function. But when I read the article down below, it says that this function is a better fit for getting a random integer, and when I read its source code and try to understand what it does, it makes sense to me because math.random gives a pseudo-normal distribution of random floating point numbers that are less than or equal to 0 and strictly less than 1. And this formula will definitely give a number between min inclusive and max inclusive. And this is another useful habit to have. What I mean is what you read, especially on the internet, may not be always true, or it might be incomplete, or it can be outdated. So never trust what you read, and always understand what a function, tool, or library does before using it. So I have 25 rows and 25 columns. So to get a random row, I can call getRandomInt0 and number of rows. And to get a random column, I can call again getRandomInt with 0 and the number of columns. I'll also rename getRandomInt as randomInt since it's a function without any side effect, so I prefer using a noun phrase instead of a verb for it. So let's display a random row and a random column inside this game loop. And I get an error. Calls is not defined. Because I named it columns, not calls, and actually my IDE is hinting me by rendering this variable in a grayish color, indicating that it's not used, so I'll rename it as calls because, well, it's shorter. And now I can see random rows and columns on the console. And next thing I want to do is to draw something at this random coordinate, which will be our apple that our snake is going to eat. And our drawApple function can take a row and a column, so I can pass them as two separate parameters like this, but that might be error prone, like in the future I might forget or confuse the order of these parameters and pass a column index instead of a row index and vice versa. So instead I'll destructure an object literal as a function parameters like this. And our drawApple function will do the same too. Now how do we draw an apple? Well, let's search for it again. For starters, I just want to fill the apple square with red, which is an appleish color. And when I search for canvas context fill, I again get an API doc that explains me how I can do it. So I'll do a context fill style and give it a color. Then I'll do a context fill rect and provide the x and y coordinates and the width and the height of the rectangle that I'm going to render. But these random rows and columns are just indexes of a 25 by 25 array. So to convert them to the actual pixel dimensions, I need to multiply them with our grid size, which is 16 pixels. For that, I'll again define two variables, grid width and grid height. Both of them will be 16 pixels again. And then the number of rows will be canvas width over grid width. And the number of columns will be again the same, canvas width over grid width, because like I said, this is a square, so the width and height of it are the same, and therefore the number of rows and columns on it are the same as well. Then I'll do a context fill rect, row times grid width, column times grid height, and our apple will be grid width by grid height, so I'll put them here too as parameters. And when I save the file and refresh the page, I get this fill style is not a function error because, well, from the documentation again, fill style is an attribute that we need to assign the color to. It's not a function. So let's fix it and retry. Well, it's working, I guess. We are placing random red apples all around our canvas. And I think I can make one tiny adjustment. Currently there is no space between those squares that I draw, so it doesn't look quite grid-like. So if I create some pseudo borders around them, like if I paint those squares a little narrower to leave some gaps between them, then I think it will feel more grid-like. So to test it, I'll define a grid gap variable and set it to 1 for a 1 pixel gap. Then down at the fill rect function, I'll subtract the grid gap from the width and height of the square. Let's save it and refresh the page. And yeah, it's now more like a grid, I guess. Now what I want is not to fill the canvas with apples all around, but instead I want to draw a random apple at a random position at every game loop iteration. And for that I'll need to clear the canvas and repaint it, placing the apple to a new position. So let's search for canvas clear, and yeah, the 2D context has a clear rect function that we can use. So I'll create a clear canvas function that will call this context clear rect with 0, 0 as x and y coordinates. But what about the width and height of the canvas that we are going to clear? Well, we know that the width and height of the canvas is 400. But it's better to define a constant for it and use it instead of using magic numbers. So I already have canvas width here, but to be semantically correct, I'll also define a canvas height variable, and both of them will be 400 since our canvas is a square. And I'll also modify this calls variable and set it to canvas height over grid height. And actually, this should be reversed. When you divide canvas width to grid width, you get the number of columns. And when you divide canvas height by grid height, you get the number of rows. But since the canvas is a square, nothing will change and those two numbers will be equal to each other. So I'll pretend that I haven't seen this mistake and I'll move on with the rest of my code. Which is dangerous actually, because if somebody decides to, say, create a rectangular snake game instead of a square one, then our game logic might not work as expected. So those mistakes almost always happen no matter how careful you are. And when writing code, making mistakes and introducing bugs and regressions are inevitable. So how can you figure out this particular mistake? Well, by writing unit tests around this application, of course. In one of those unit tests, for example, you can initialize a rectangular canvas instead of a square one, and then try to position the apples on it, and then realize that some of those apples are being rendered out of the boundaries of the canvas. But I'm leaving that part as an exercise to the interested. Also make sure to check out the lesson notes on this video's webpage for various approaches that you can take to write unit tests around an HTML game application like this. So the last two parameters of our clear canvas function will be canvas width and canvas height. And also note that I'm calling clear canvas before every game loop. But when I refresh the page, nothing happens. So what's wrong? Let's look at the developer console again. And it looks like I made another typo. Instead of clear rect, I wrote clear react. That also happens all the time, and it's normal to make typos like this. So we are going to fix this and retry. Now we are randomly placing an apple at every game loop. So far so good. So we have our apple. How about the snake? How are we going to render it? Since this snake visually looks like a linked list of some sort, I think initializing a data structure for it will be helpful to better reason about it, so I'll do so. Our snake will be an object literal, and it will have an x and y coordinates to locate its head, just like our apple. But when it comes to rendering the snake on the canvas, I always confuse what's the x and what's the y coordinate of the canvas. So I'll do a neat trick and I'll fixate one of the coordinates of this fillRect function and observe how the game engine reacts to it. So I'll fix x to 10 and I'll leave y as a free independent random variable. And in that case, the distance of the apple from the left side of the rectangle remains the same, and the distance of the apple from the top of the rectangle changes, which also means that for x, I need to step by the width of the grid, and for y, I need to step by the height of the grid. So let's position the snake's x coordinate to 10 times the grid width, and its y coordinate to 10 times the grid height. And also our snake will have some speed because it will be moving on the game area, chasing apples over and over again. So for simplicity, I'll model the snake to have a constant speed on either x or y axis. And for extra fun, you might try to modify your snake to have some acceleration when changing directions, for example, because it's your world and it's your rules. But again, I'll leave that as an exercise to you. So I'll define a velocity and its delta x will be the grid width, which means the snake will move one grid at each game loop on the x-axis, which means initially our snake will not move on the y-axis, it will only move on the x-axis. I'll also need to remember the cells that the snake covers, and I'll also need a maximum number of cells so that if my render logic exceeds that much cells, I'll just exit my render function or do something, I don't know. I'll figure it out later, but I feel like I need that constraint, so I'll just put it. Let's also attach a move function to this snake object. So when the snake moves, I'll increase its x and y coordinates by dx and dy, which are the components of our velocity vector. So after clearing the canvas, let's move our snake and then log it. Well, again, I made a mistake because I am referring to this in a fat arrow function, which will not work as I expect because fat arrow functions are lexically bound. That means they don't have their own this and they use the this from the closest context. So let's turn this into a regular function and retry. Now you see that the x coordinate of the snake is changing, but it's changing indefinitely. And what I want to do instead is similar to the Nokia 3310's snake game. I want my snake to wrap around the game area if it goes out of the boundaries of the canvas. So for that, I'll add a few conditions. So if x is greater than the canvas width, I'll teleport the head of the snake to the other side of the canvas by setting x to 0. And I'll do the same thing with the y coordinate as well. And if x is less than 0, I'll do the opposite and I'll do the same with y as well. Now let's save this and refresh the page. And yes, now the snake reaches to 400 and it loops back to 0, which is what we want. we want the snake to wrap around the canvas. Also, as the snake moves along, I want to create a cells collection that I'll render on the canvas one by one to paint the snake. So for that, I'll unshift a cell, and while I do that, I'll also look up for how unshift works, because honestly, I always confuse those array methods, so I want to be extra sure that I am using the correct function. And as it happens, unshift is what I want because it pushes stuff to the beginning of the array. So we'll save and refresh the browser. And the problem is now the cells are increasing without boundary. What I want instead is if I exceed the number of cells that my snake is supposed to have, I want to remove the last cell from the tail of the snake to leave some space for the new position of the head. Which simply means that I need to remove the last item, which can be done with this pop method of the array. So I'll pop out the last item. So if this cell's length is greater than the max number of cells that the snake can contain, we'll pop the last cell from the tail to leave space for the brand new head that we'll render. Let's once more log the snake's cells to see how it looks. Well, at least the size of the array does not increase as it did before. And to see things clearer, I'll convert this array into JSON by json.stringify. And yep, it looks like our snake is happily moving to the right and then wrapping around the corner. So let's visualize it to see it better. Here I can take two different approaches. I can either create a drawSnake function, or I can create a draw method on the snake object and then call snake.draw. And since this is a game and we are dealing with objects like apples and boards and grids and snakes, this is more like an object-oriented design. So I think an object-oriented approach is better. So I'll just create a draw method on the snake object and call it here. Or actually, let's name it render. So we'll call snake.render. And similar to apple, I'll also assign a fill style for the snake. And this time it will be green. But again, these colors might change in the future, so it's better to define constants for them instead of using them as magic strings in here. So I'll define two constants, one for the color of the apple and one for the color of the snake, and use them in the code. So the fill style of context will be color_snake, and for each cell of the snake, I'll render the cell. And again, probably I can isolate this square render logic in its own function and I can reuse it, but I'll be lazy and just copy and paste apple's render code down to the snake's render function. For the x coordinate, I'll use the cell's x coordinate, and for the y coordinate, I'll use the cell's y coordinate. And when we save and refresh, we see a tiny little green moving snake. So that's some progress, I'd say. So what next? We need to control the snake, and to do that, we'll use the keyboard, and in our case, we'll use the keyboard's arrow keys. And when I tap the arrow keys, I want to change the snake's velocity vector to reorient the snake. So for that, I'll create 4 methods on the snake object: orient left, orient right, orient top, and orient bottom. And for each of these methods, we'll change the velocity vector of the snake as you see here. So now to control this snake with my keyboard, I need to add a key event listener to my page. So I search for how to add an event listener, then how to listen to keyboard events, and more on keyboard event codes and stuff like that. And after gathering enough knowledge, I decide to attach this event listener that I want in an isolated listen function and call that function just under this loop initializer. So again, from the MDN documentation, there are quite a few key events that we can listen to. But this key down event looks like the best option that we have, since it's triggered repeatedly, so it can give a snappier control over the snake. So I'll use that. Also, when reading the documentation, I realized that each key event has a key code. So what I'll do initially will be just to log the key codes to verify that my UI is at least understanding and responding to my typing events. And it looks like it does. And again, I'll define the key codes that will trigger certain actions as constants. I'll create constants for up, down, left, and right key codes. And also I'll define constants for WSAD keys for those who prefer a Quake-style navigation. Then I'll switch on the event key code. And if the key code is up or alternate up, we'll orient the snake upwards. And if it's down, we'll orient our snake downwards, and so on. So when I try the down arrow, it works, but after a few key combinations, I get a key_top not defined error on the console. So I go to my constants section, and rightfully so, instead of key_top, I'd name my constant as key up. So I'll use key up and key up alt in the switch case to fix this naming error. And now we are all set and our snake is moving. I'll also increase the speed of this game a little, because this snake is a little slow for my taste, and 8 looks good enough, I guess. And when I refresh, yeah, that's the snake that I want to play with, I guess. It's fast enough. But there is still something weird. For example, if the snake is going right and I move it to left immediately, it will start moving over itself, which looks odd, and it can also complicate the hit detection calculation that we'll do later in the game. So I don't want the snake to backtrack itself, so I'll add a bunch of conditions to prevent it. For example, if the snake is going right, it should not turn left. It should only be allowed to go upwards or downwards. And those checks are indeed pretty straightforward. In the orient left and orient right function, we'll allow the snake to change the direction only if it has a 0 horizontal velocity, otherwise we'll simply return. And we'll do the same for the top bottom functions as well, and we'll let the snake move only if it has a 0 vertical velocity, and otherwise we'll just bail out again. That kind of fixes this backtracking problem, and our snake is moving happily in its little garden chasing apples. And since we modeled our snake as an object, maybe we can model the apple as an object too, for the sake of consistency. So let me comment out these apple drawing code first and think about how we can model this apple. Essentially, our apple will be not different from the cells of a snake. It will have an x coordinate and also a y coordinate, and I'll arbitrarily place our apple on row 16 and column 16 of our 25 by 25 garden. And similar to snake, our apple will have a render method, so I'll just cut and paste this draw apple logic into its render method. Instead of call and row, we'll use the x and y coordinates of the apple, and we should be good to go. But when I refresh, I see that I made another typo, so I'll fix it and retry. Then I'll call apple.render before rendering the snake. And I'll save and refresh again. Well, I don't see any apple, but why? Maybe there is some boundary problem, so let's try to move this apple a bit closer, like to the position 5 by 5, and save and refresh again. Well, still no luck. Is my render function running? So let's put a log here. Well, it is, so that's weird. Maybe I should log the coordinates of this apple to see what's going wrong. Actually, I know what's wrong. I'm multiplying these coordinates with the grid width and the grid height twice instead of once, and that's throwing the apple out of the boundaries of this canvas. So let's delete these two and try our luck again. And I'll also put this apple to 10 by 10 to see how the snake appears to eat the apple. And yes, we have the apple and the snake coexisting happily on the garden. But there is one major thing missing. The whole purpose of the game is to make the snake bigger by eating apples. But no matter how hard I try, the snake does not eat the apple. Because, well, we haven't told it how to eat an apple yet. So let's think about it. What is eating an apple? For one, when the snake eats an apple, it will grow in size. And secondly, when the snake eats an apple, the apple will disappear and it will reappear in a random location on the garden. But even before that, I need a way to do collision detection, which you'll have to do a lot in game programming. And sometimes you might need to get really clever or use a framework that does collision detection efficiently. But in our case, just checking whether both x and y coordinates of a snake cell and the x and y coordinates of the apple overlap would be sufficient, so we don't need a big library to implement it. So let's try to create a collides with apple function that takes a snake cell as an argument. So the function will return true if the x coordinate of the snake cell is the same as the x coordinate of the apple, or the y coordinate of the snake cell is the same as the y coordinate of the apple. It makes sense, right? Then I move this function all the way to the top to avoid hoisting and temporal dead zone problems that I may have. And similarly, I'll move apple to the top of this function, not because it will cause a bug if I don't do so, but because I want to keep my dependencies in order. I mean, I want to define objects, constants, and functions before defining other objects or functions that use them. Or to put it simply, since Apple is used by this collides with Apple function, I prefer to define Apple before collides with Apple. This also helps me think about stuff like whether it makes sense to define the collides method on the Apple object itself, as in apple.collides snake cell, or is it better to keep it separately like this? And if the method was far down below, as we had before, I probably wouldn't have thought about this refactoring at all, because it would not have been this easy to see and realize. So as a rule of thumb, keep your dependent objects and functions close to each other, and define objects, methods, and constants and functions before they are being used. So what I'll do is, if the snake collides with Apple, I'll increase its max cells, which will cause it to add one more cell to its tail, which would appear as if the snake is eating the apple. And at that point you can do all sorts of fancy animations, like rendering the intersection square a bit bigger to give an illusion that the snake has actually ingested the apple and there is this apple bulge moving through the belly of the snake towards its tail, but I'll leave those effects as an exercise for the interested again. And after that modification, I'll move the apple to a random position with these helpers that we created during the beginning of the lesson. But when I play the game, something is not right. I mean, the apple is jumping around like crazy and the snake is being weird, to say the least. It's growing, but in a weird way. I cannot explain what it does. So probably I have a collision detection problem. And to debug it, let's see what happens inside this collides with Apple function. And as an aside, when doing game programming, logging things are a much easier way to debug stuff than, say, setting breakpoints. Because in the game everything changes at every game loop, and if you set a breakpoint it might be too granular and it might be harder for you to see the big picture. Reading the logs, on the other hand, will show you how your objects on the game world change their states over time, and it will be easier to reason about them when you see how, for example, the velocity or the position of an object changes incrementally. So although in a typical web application, setting a breakpoint is the best way to debug it, in an HTML game, reading the logs most of the time proves itself to be much valuable than using breakpoints. So when I check the log, I see that the snake collides with the apple at all times because, silly me, instead of ending these two conditions, I OR'd them. So whenever the snake is horizontally or vertically aligned with the apple, our algorithm thinks that it was intersecting with the apple, which is not correct. So let's replace this OR with an AND and retry. And yes, now my snake is happily eating the apple, but what's that? The apple is gone and the new apple that I created is not visible. So I'll make an educated guess and say that this is probably again a boundary condition or an off by one error or something, and probably I have placed the apple somewhere outside the boundaries of the canvas. So I'll refresh and retry. Well, it looks like now it's working, so I don't know. I'll take a note of it and investigate this further, since this looks like a Heisenberg bug that shows itself once and hides itself away when you start observing it. But at any rate, if I see this Heisenberg bug again, I'll take a closer look, but I want to deal with it later. So the next rule of the game is to detect the snake intersecting with itself. For that, let's create a function and call it as apply game rules and pass the snake and the apple as arguments to it. Or maybe call it as verify game end, because I think it's a better name since it detects whether the snake has eaten itself and the game is over, so we need to restart the game. So how do we verify the game end? Well, at each render step, if the current cell that I'm rendering is intersecting with any of the cells of the snake, then I'll consider it game over. Also, when I render a cell, it means that I have verified that that cell is not intersecting with any of the snake's remaining cells. So for the next cell, I can just skip the cells that I already created and do the collision detection test with the remainder of the snake. This will reduce the problem set I'm working on every single iteration. So I have scribbled some code here, but that's probably wrong, but it's still worth giving a try because those two reset functions are commented out. So this change at least should not alter the game, since I'm not calling these reset methods on neither the snake nor the apple. So let's refresh. Okay, that's it. Again, I'm having this disappearing apple problem. I better solve it before moving on with the endgame logic. So let's log what we have as an apple. Console log new apple, and also I'll fix this typo. And now I see the apple is gone because we are rendering it at y equals 400, which puts it right out of the border of this canvas, which means that our random row and column generator function also has a random off by 1 error. So let's fix it. Instead of returning an inclusive boundary, I'll return a random integer that includes min but excludes max by removing this +1, and that should fix it, I guess. Well, that's fixed, I think, but also I'm having a disappearing snake issue here. Well, I'm doubly lucky, I guess. Again, it's an off by 1 error probably, and similar to apple, when I log the snake's coordinates, it renders it at y equals 400 if I try hard enough. So how do we fix it? As it happens, by changing this boundary condition from greater than to greater than or equals, and doing the same for this x here too, we'll manage to constrain the snake within the boundaries of our canvas. Now, no matter how hard I try, both the apple and also the snake will always be rendered within the game area, which is good. So back to our endgame logic. Instead of cell, I want to pass this cell index to the verify gameEnd function because snake already has the info about its cells, and passing this entire cell again feels a bit redundant to me. And as we discussed, for each cell that is after the current cell, if the x and y coordinates of the current cell overlap with the cell that we are checking, that means that the snake is overlapping with itself. So we'll reset the snake and also we'll reset the apple, which will end the game and restart a new game. So how do we reset the snake? Let's start by creating this reset method first. Well, to reset, we need to redefine its attributes to their initial values. So let's do that by resetting x and y, and also velocity dx and velocity dy. And how about apple? Well, to reset the apple, we'll put it to a random location on the grid. So the game initially looks fine, but after eating the apple a few times, the game has gone haywire again. Well, I don't know what the hell is happening here, but there's something definitely wrong with this reset logic. And since apple's reset logic is relatively simple, I'll make an educated guess and take a stab at the snake's reset function first. And yeah, it looks like I have forgotten to reset the snake's cells collection and also this max cells variable. So let me do that as well. And finally, I guess our game is now relatively bug-free. I might still consider breaking this for loop after ending this game in verify gameEnd as a clean programming best practice, but I can leave it as is as well, because since after this snake resets itself, it will reset its cells too, which will make the snake.cells.length equal to 0, and it will consequentially break this for loop anyway. And I can also do some minor refactorings to organize the code better, but again I leave that as an exercise to you. And as a final touch, I want to change the colors of the game a bit because they are too vibrant for my taste. And for that, I'll use a tool called Xscope, while you can use any color picker you like. So I'll pick the green and red and some other background colors from my IDE and apply them to the code and also to the CSS. And when I refresh the page, here's the final snake game. So in this lesson, I try to show you how I'd solve an actual development problem in real life or in a situation as close as it gets to real life without cutting out my mistakes and without polishing anything. And that's why it took a bit longer than usual. And I hope it was useful. If this were a regular lesson without any of those mistakes and commentary, it would have looked like as if I'm magically solving problems with great speed and accuracy, and this entire lesson would have taken at most 5 to maybe 10 minutes. But instead I try to focus and share my thought process and how I would approach to development problems in real life. And I hope it was as fun for you to watch it as it was fun for me to create it. As always, you can fetch the source code and the lesson notes from this video's webpage. And until the next lesson, may the source be with you.